Hello, welcome to this lesson looking at the potential difference laws in electrical circuits. Now this particular lesson is focused on AQA Physics and AQA Combined Science Unit 2 of each course Electricity. Now in today's lesson we're going to look and define the laws that govern potential difference in electrical circuits. So the following ideas will be our learning outcomes. We're going to try and firstly state the basic definition of potential difference. We're then going to look at how potential difference can vary in a parallel circuit, and then we're going to look at how potential difference varies in a series circuit, which is linked to the following part of the specification. So as you can see here in the AQA Combined Science and Separate Science specification, you need to be aware of A, what a series and parallel circuit are, then in these particular circuits, how current can change in these circuits, how potential difference can change in these circuits, and then lead that onto how resistance can be changed in these circuits as well. So, firstly, in electrical circuits, there are two main types of circuits. There's series circuits and there's parallel circuits. Now, a series circuit is basically a circuit with one loop of electrical components. Now, basically, in a series circuit, if there's a break in the circuit, all of the circuit will stop working. Now, another way of describing a particular loop of electrical components is a path. So another way you can define a series circuit is basically a series circuit is one big loop or one single path for the charge to flow down. So like in a TV series where there's one episode after another episode after another episode, in a series circuit there's one component after another component after another component. Now a parallel circuit is a circuit with more than one loop or more than one path for the electrical components. So here there'll be multiple paths that the charge can flow down in this circuit. Now a posh name for path in a parallel circuit is called a branch. Now in a parallel circuit, if there's a break in the circuit, only the branch with the break in will stop working, and each branch takes the same amount of energy from the batteries from the battery. So more branches or more loops or more paths, that means the more energy that's drained from our source of potential difference. So just to clarify, a series circuit is a circuit with one loop or one path of electrical components, whilst parallel circuits are more than one loop or more than one path of electrical components. Now each loop or path we call a branch. So here, for example, is a diagram of a series circuit. It's just one large loop. Now just to clarify, you'll see there's a second loop there with a voltmeter. Now a voltmeter doesn't actually count in this particular loop. It's a bit of a special case in this particular example. Now when we draw our circuit diagrams, try and draw them so they're a large size, use a pencil, use a ruler, so you can clearly see the components and that there's no breaks in the circuit. Now here is an example of a parallel circuit. Now similarly to the series circuit, make sure your circuit diagram is drawn to a large size with a pencil and with a ruler so you can clearly see the components and that there's no breaks in the circuit. Now just remember, like we said before, a parallel circuit has more than one loop, and each loop we call a branch. Now, there are three laws that govern electrical energy transfer in circuits. Now, we call these laws Kirchhoffs Laws because they're named after the physicist Gustav Kirchhoff, who discovered them or wrote them down in 1845. Now, Kirchhoff's first two statements relate to the current in a circuit. Now, we talked about this previously, but current is the rate of flow of charge, which in most cases is electrons in a wire. Now, the first rule, the first statement, is that at any junction in a circuit, the total current leaving the junction is equal to the total current entering the junction. Now, just to clarify, a junction is a place in the circuit where electrons have more than one possible path to travel down. Now, like we said before, this basically means the total current into a junction is equal to the total current out of a junction. So this can be shown in the following example, that there's 6 amps going in and that there's 2 and 4 on each individual path coming out of the junction. So 4 plus 2 equals 6. So if 6 amps are going in, 6 amps are going out. Now the second law also relates to the rate of flow of charge in the wire. And the second rule is that in a loop, the current is the same throughout the loop. So in a series circuit, the current is the same everywhere when it's measured. So it doesn't matter where you place your ammeter in a series circuit, it should always read the same value for current. So along a single path, the current is the same everywhere along that path because a series circuit is just one single path. So this can be shown in the following example. No matter where you place your ammeter in this loop, in this single path, it's always reading the same value for current. So just to clarify, the current laws for electrical circuits are that in any junction in the circuit, the total current leaving the junction is equal to the total current entering the junction, and that at a single loop or a single branch, the current is the same throughout that loop or branch. So we can summarize our laws for current in the following ways in for series and for parallel circuits. Okay, so what we're going to do is we're going to interpret Kirchhoffs laws in the situation of series and parallel circuits. So in a series circuit, current will stay the same, but in a parallel circuit, the current is shared between the different paths of the parallel circuit. So now we've looked at current, let's look at potential difference. So to understand what potential difference is, we've got to understand what is in wires or conductors. So metal wires are full of delocalized or free electrons, electrons not bound to any nucleus or any ion. Now the greater the number of free electrons, the better the electrical conductor. Now we can place a potential difference across a wire, across a wire, which can make the electrons move the direction. Now a potential difference places a positive and negative charge across the wire. So the electrons move to the opposite charge, which will be positive, and move away from the same charge, negative. So the electrons will be repelled by the negative and they'll be attracted to the positive, and so as a result they'll all move in the same direction. Now in most circuits a potential difference is provided by a battery or by a power pack or the mains. So you'll get repulsion from the like charges will be negative and attraction from the opposite positive charge. So the potential difference will cause the electrons to move in the same direction. So for an electrical current to flow through a closed circuit, the circuit must include a source of potential difference. Fundamentally, a potential difference causes current to flow when there's a complete circuit. Now, by full definition, potential difference is the ability for free electrons, the charge, to do work. So basically, it's the amount of work done per unit charge in the circuit. So its work done is fundamentally the amount of energy transferred or store changed. So as a result, potential difference is the amount of work done or energy transferred per unit charge in the circuit. So the potential difference can lead to a current because the potential difference is carrying out work into the circuit which allows the electrons to flow in a current. So fundamentally, the potential difference is the energy transferred or work done to move the charged particles, which is in most cases are electrons, in a current per unit charge. Now the potential difference is provided by either the battery or the power source in the particular circuit. So a battery can act as a source of potential difference, and they're normally between 1 volts and 10 volts. A battery's potential difference is normally a lot lower than the mains. Now a power pack can also act as a source of potential difference, and if you're looking at the mains potential difference is 230 volts. So we're going to look at the following ideas. How does potential difference behave in a series circuit? How does the potential difference behave in a parallel circuit? And does it behave any differently to current? So, basically, to understand Kirchhoffs' second law, or the potential difference law, we've got to consider what's going on in a circuit. Now, basically a power pack, a cell, or a battery can place work into the circuit. It's causing energy per unit charge to be placed into the circuit. Now at A level, we call this particular idea the electromotive force. Now, an example of this is a power pack. So the power pack has an EMF, or electromotive force, so it allows energy per charge to enter the circuit. So fundamentally, it's transferring the store from one particular store to another store and putting energy into the circuit. Now, also as well, we've got some outputs in our circuit. So these are potential droppers. These are outputs which are transferring energy out of the circuit. Okay, so work is being done out of the circuit per unit charge, and we actually call this particular idea at A level the potential difference. Now, an example of this will be a light bulb. So a light bulb has a potential difference. It allows an energy per charge to leave the circuit. It's turning an electrical energy store in the circuit into the internal energy store of the surroundings, heat, okay, light, those particular ideas. Now, in one closed loop or system, there's a potential rise, an energy per unit charge added to the circuit, and there's a potential drop. There's an energy per charge leaving the circuit. Now, in a closed loop or a closed system, the total potential difference in equals the total potential difference out. So the potential difference in the loop will actually split in proportion to the resistances of the output. So the higher the resistance, the higher the potential difference of the output. So if the resistance is double, the potential difference is double. Now, just to clarify this again, for a complete loop of a circuit, the sum of the potential difference going into the circuit equals the sum of the potential difference going out of the circuit. Now, this can be shown in this particular example that we've got 12 volts going in from the power pack or the cell in this particular example, and we've got 3, 3, and 3 there, okay, which works out, I should say 4, 4, and 4 there, because if you've got 12 going in, you should have 12 going out. So as a result, okay, you've got 12 volts going in and 12 volts going out. In this particular example, we've got 18 volts going into the circuit, and so we're going to have 18 volts going out of the circuit. So we've got 6, 8, and 4. Now you might think, why have they not split equally? Well, the amount of potential difference each particular light bulb will receive is due to their resistances. So this tells me that the middle bulb has a higher resistance than the other two bulbs, so will take more potential difference. Whilst the bulb on the far right has the lowest resistance, so will take the least amount of potential difference. So, to summarise the laws of the electrical circuits, what do we know? That the current, okay, in series it stays the same, but in parallel it splits because there are junctions, there are more than one path, and the charge will split down the different paths. But in potential difference, in a series circuit, it will split between the different outputs because fundamentally the potential difference in has to equal the potential difference out. So if there's more than one output, it will split between them. But in a parallel circuit, because each individual loop is treated separately, because they're separate systems, they're each individual loops, therefore each loop gets the same amount of potential difference, so it stays the same. So to clarify, what should we have learned in today's lesson? Number one, we can hopefully state the basic definition of potential difference. We can describe how potential difference varies in a parallel circuit, and we can describe how potential difference varies in a series circuit. Hopefully, you can carry out all those particular tasks, and I hope you've enjoyed this particular lesson looking at the potential difference laws in electrical circuits. Thank you very much and have a lovely day.